All right, suppose a normal model describes the fuel efficiency of cars currently registered in your state. The mean is 24 miles per gallon with a standard deviation of 6. So we can write the model as n parentheses 24 comma 6. Remember, that tells you the shape, the center, and the spread. When you see that, the 24 is your mean and the 6 is your standard deviation. It says sketch the normal model. So we're going to draw our model. And it's okay if yours isn't as pretty as mine. I've been practicing for a long time.
So does that mean to the right it's going to be plus 6 and to the left it's going to be minus 6?
Right. We're going to add 6 to the right, and we're going to subtract 6 to the left to get positive 1 standard deviation, which is 30. Positive 2 standard deviations would be 36. And 3 standard deviations would be 42. So we add 6, add 6, add 6. Yes?
How do you charge the calculators?
Okay, so now we're going to subtract 6 for 1 standard deviation below. So 18, 12, and 6. Okay, so the question, this is 1, just draw the normal model. We know that 68% is between 1 standard deviation. 95% is between 2 standard deviations. Approximately, we're going to get the actual percentage today. And 99.7 is between 3 standard deviations. Okay. So here's your... So number 2 says, what percent of cars get less than 15 miles per gallon? And we say less than or equal to or less than. It doesn't matter. We use 15 as our lower or as our boundary because there's no area. Like, we're really looking at the area under the curve here. So there is no area at a single value. It's calculus. So here's 15. And we want to know what this area is. Okay. Yeah, you don't know what that area is? Is it off the top of your head?
What did you say? 16 plus 1.25?
No. No, you're not supposed to know this yet. That's why I'm teaching it to you today.
I have no idea. Yeah. Why did you say I'm supposed to know?
So we find a z-score. Okay, we're going to find a z-score, and we have this amazing function in the calculator called Normalcdf, which will calculate the area under the curve for us if we give it a z-score and a lower boundary. Okay, so the z-score is remember, x minus mu over sigma, right? This formula is not going away. So my x is what? 15. The x is what the question asked me. So the question asked me for what percent of all cars get less than 15 miles per gallon, minus the mean of 24, divided by the standard deviation of 6. That's the information it gave me in the problem, right? Mean of 24, standard deviation of 6. Which is negative 9 over 6, negative 3 halves, negative 1.5. Okay. Now, to find that exact area, like I said, you would have to use an integral from calculus and blah, blah, blah. But the calculator has a function in there that does all that fun stuff for us. Okay? So the function in the calculator is called Normalcdf. Okay? It's in the second bars menu. If you look above the vars button, hold on, I'm going to put a little camera in here for us. Right here it says vars. Trying to get the focus. The vars button is right here next to clear. So oh, you gotta turn it on. Second, vars. Guys, you have to know how to use the calculator. There is no other way to get this information other than using a table, and you don't know how to use the table either. So you've got to learn how to use the calculator, so you've got to be paying attention to this part. Okay? If I hit second vars, I'm in this distribution menu, and we have two things at the top. We have normal PDF and normal CDF. We never use normal PDF. Okay? We always use number 2, normal CDF. Okay, so you're at second, the vars button, and that gives you, see it says distribution is what it stands for. And we're going to use the normal CDF function. Hit enter on that. Okay, this is asking you for a lower boundary and an upper boundary. You will always leave this as 0 and 1. Okay? To change that and use this function with the actual mean and standard deviation is cheating. Okay? You will not be given credit if you don't leave this as 0 and 1 and calculate the z-score. So I don't show you how to do that because you don't get credit for that on the AP exam or my tests. So don't use the shortcuts. Okay, there's certain things we expect you to be able to do. Calculate the z-score. So when I look at my distribution, my lower boundary, we're either going to use negative 99 for a lower boundary or 99 for an upper boundary. In this case, negative 99. And my upper boundary is negative 1.5. Okay, I'm going to explain why in a second. Basically, less than, right? We were asked for less than 15 miles per gallon. Less than is an infinite, right? It goes infinitely to negative numbers, okay? So we're telling the calculator to calculate the area under the normal curve from negative 99 standard deviations, that's pretty far, right? To negative 1.5 standard deviations. So negative 99 and positive 99 are going to be our infinity numbers when we have a one-sided inequality. Greater than, we're going to use 99 as my upper boundary, and my z-score is my lower boundary. And less than, my lower boundary is negative 99, and my upper boundary is my z-score. And then I can also put in 2 z-scores and have it calculate between them. So now we're going to go to paste. You're going to see me write it on our paper this way without the 0 and the 1. Okay? So when I write on our paper, normal CDF, parentheses, negative 99, comma, negative 1.5, close parentheses, those are your upper boundary and your lower boundary in your calculator, and you can hit enter. And that is the area under the curve less than 15 miles per gallon. Okay. So now we get rounding happy. Do not round too much. If you say this is 0.07, you're going to get marked off. You need to have 3 numbers behind the decimal, and that doesn't include leading zeros. Okay, I want 3 numbers at least. 4 is better, but my 4th is a 0, right? So at least 3 or 4 numbers behind the decimal. Do not round. Do not round this to 1 decimal place. Okay? So we can say Go away. We need to say at the end, I want your answers in a sentence. 6.68% of cars get less than 15 miles per gallon. That's what I answered, right? Question 3. All right, let's look at the third example. What percent of cars get between 20 and 30 miles per gallon? Okay, so that's the question. What percent of cars get between 20 and 30? That's going to be about here to here. I want this area between 20 and 30. So I have to find the z-score for 20 and the z-score for 30. Okay, so I'm going to... The z-score for 20 is 20 minus 24 over 6, negative 4, 6, which is negative 2/3, right? We can actually put the... we can actually put the fraction into the Normalcdf button. So we can use... the decimal is point, negative 6 with the bar on top. But we can just put the fraction into the Normalcdf part. And then 30 is 1, right? Question. Who had a question?
So if
We're going to Normalcdf. We're going to put in my lower boundary as negative 2/3 and my upper boundary as 1. Yes.
Whenever we go to the Normalcdf, will it always go to -1e99?
If you haven't used it before, yeah. It will go, if you reset, if you turn it off, yeah, it goes to -1e to the 99. You can leave that in there. When the calculator says -1e to the 99, that's like 10 to the negative 99th power, which is fine. Negative. Okay, so again, in your calculator, second vars, Normalcdf, it usually has what you put in it last, okay? If it says -1e to the 99 here, that's -1 times 10 to the 99th power, which is very large, right? The point is to make the lower and upper boundary be infinity if you need it to go to infinity. So it's okay, you can leave it like that, or you can change it to -99 and +99. But this time, my lower boundary is a z-score. I want between two z-scores. So I'm going to put -2 divided by 3. I don't have to round the decimal. I can put the fraction in. Put the fraction in. That's going to give you more accuracy. And then +1 and paste. And then I hit enter. So it's .589. Right? This one rounds that one up. So 0.589. 3 numbers behind the decimal place.
That's for the 20, right?
What? No, that's between 20 and 30. You can put the lower boundary, the z-score for 20 in, and the z-score for 30 as your lower and your upper boundary. It's going to tell you between. Okay? So 58.9% of cars get between 20 and 30 miles per gallon. So when its x is less than a number, okay, we use normal CDF, negative 99, comma, the z-score for that number. When it's between, it's normal CDF. Your lower boundary is z-score 1, and your upper boundary is z-score 2. And when it's x is greater than a number, we use normal CDF. The z-score, comma, positive 99. What percent of all cars get more than 40 miles per gallon? So that's x is greater than or equal to 40. Okay, you're going to find the z-score. Your steps are find the z-score. And then use normal CDF to get the percent. When we calculate this z-score, we get 40 minus 24 over 6, which is 16. 6 reduces to 8/3. Okay? That's 2.667. Okay? Again, I'm seeing you round that to 2.6. And your answer is going to be off when you round too much. Look at the difference. Okay? Hold on, normal CDF. Because it's greater than, our lower boundary is the z-score, comma 99. I want to look at the difference between all of these. Look at these four differences. Okay? These two are really close. Okay? Now, granted, we are still looking at the 10,000th place, right? Now we're here with these twos, this 2 and this 3. We're in the 100,000th place. Okay? Not a huge difference between these two. Okay? So it's okay to use this or this. But the minute we round it to 2.6, now my thousandths place is off. Right? We're at the difference between 0.3 and 0.4. And then 2.7 was a little bit closer. The thousandths place was right. But this one is off more. Okay? You don't want to round too much. Okay, that's why I say 3 numbers behind the decimal place. Always. Okay, don't count the numbers in front. 3 numbers behind the decimal place. Now, if there's a 0 between, if it's like 2.067, that counts as 3. But if it's just 0.0, right, these leading zeros, they're all zeros, don't count. You want 3 numbers, okay? You really need to make sure you are not over rounding, okay? So we don't want this or this. You want 3 numbers behind the decimal, not including leading zeros.